So today I would like to present a feature isolation in Flutter apps, and what is feature isolation, what inspired it, and what it means, and how we can do it. So without further ado, just a few things about me. I work for Ping Pong, an early startup that focuses on asynchronous communication using media channels like video, audio, and screen recording. I have over 15 years of experience in the industry, and right now I'm very happy because I was building the communication tool using Flutter, React, and Node. If you want to know more about it, just go to the website getpingpong.com and you can get an early access. But enough about that. So my community activity. So as Vaya mentioned, I was involved before the version 1 days, as many people have, and fell in love with it. Started using some libraries, so I saw some common patterns in all my projects and extracted them into some libraries under the group name Flutterings in GitHub, so you can check them out there. I am organizing the Flutter Greek community, which we are having meetups for and talking about Flutter and mobile technology. I have also contributed to the main Flutter repo, it's a bunch of commits, and recently I've been D.D.D for Dart and Flutter. So the way that I approach software development in general, and not only just mobile development or Flutter development, is based on 3 pillars. The first pillar is the test-driven development, S.O.L.I.D principle, and domain-driven design. Having said that, of course, I'm not like 100% focused on that. I can be more pragmatic if it needs to, but basically, this is what drives me. Mostly domain-driven design, which I think is an awesome paradigm to have and to work by. Yeah, so what's domain-driven design? I don't know if any of the audience have an idea. It's something that has gained some momentum the last few years, but let's see what it is. So according to its definition, is domain-driven design is an approach to software development for complex needs by connecting the implementation to an evolving model. So what this means actually is this schema. So basically what everything else tries to do. So we have like the real world and we have code. So we try to have real code represent real world. And so we check real world, we code it, then we push it to the real world, then get feedback about it, change it, and it's a never-ending cycle. The domain-driven design was coined by Eric Evans, and in the blue book you see on the left side of the screen. But Vernon Vaughan actually has an awesome book called Implement Domain-Driven Design, which is more practical and showcases practical aspects of implementing. But enough with that. Let's see some concept of the domain-driven design so that I can then we can then focus on how we can get inspired and do feature isolation. So the main concepts, of course, there are a lot of, but main concepts are you have to have an ubiquitous language, you have to have like a domain model, and you have to contextualize your domain model, and also have what's called bounded context, which is actually part of the strategic design. And this is what inspired the feature isolation. So what's a bounded context? So that's the definition, but of course, it's as any definition is very vague. So a description of a boundary within which the particular model is defined and applicable. So what it says actually is that if you have like a big ball of mud in the left, you can draw bounded context and isolate things in that big ball of mud and actually organize it in a way that makes sense and everyone can actually understand what's going on. And basically, that's the goal of bounded context. But okay, so this is what my approach is, but what is Flutter's development approach? And that's a very good question, because Flutter is completely unopinionated. It doesn't care. It doesn't care how you build your app, how you structure your app, and whatever you can use. They are only opinionated about how you build widgets, and that's about it. So developers are free to use whatever approach they are used to or they make sense to them, and there is no enforcement from the framework. Basically, what you get when you run your first Flutter create is a project with only one file. So this is the structure of the project, just one file, and you have I think you have 2 widgets there, and that's it. I'm sorry. Because it's unopinionated, this made me think, okay, so how can I structure it? I mean, what's the use? What does the Flutter team uses for structuring? So I tried to see the sample applications that Flutter team has and maintains to get inspired and see if I can extract a pattern that I can use in my apps. And what I saw was something like that. And if you see, there is a problem here, because I cannot really extract a pattern from that. I don't know if any can. So what I see is that there is no structural consistency, and there is in some cases, there is not even a name consistency. And just by looking at this code, you cannot really understand what this application is doing. You only see, some patterns, implementations, and that's about it. But you don't want to see that. You want to see, what this app is doing. So that is the major thing that I, took a step back and check code structure. So there are several ways you can structure your code. The main one is by layer. So there is you can structure your code about a presentation. You can have a presentation, a service model, and API repository. Basically, you have the layers of your project, and you just structure your code according to the layers. So you have all the presentation components in the presentation folder or package, or whatever you use. The services again in another folder and all that. But that's not really cutting it, because structuring by layer again gives you something like this. So as I said before, you have your presentation layer, you have your models, your repositories, your services, and maybe your pages. So this could be your presentation, this should be your model, this should be your repositories or API, seen both used, and you can have your services. But where are the features? So by seeing that, you don't really understand what this application is doing, because you cannot really see what the features are. So here are the features. The features are hidden inside each layer. So you have for presentation purpose, you have feature 1, feature 2, feature 3, feature 4, and so feature 1 is in all packages there. So bits of it are in the API, in the services, some UI components, it has some, and so forth. So these are the features. So that made me think, so what if we can reverse this logic and trying to have a structure not by layer, but by feature? So basically, instead of having layers, we can have feature as our main form of structure, And inside the feature, we can have, the layered components as whatever we have. Basically, just what this could turn out to be is this. So by seeing this, you can understand that, okay, I can see that this application has, like those 4 features. And those 4 features make me think that this application might be like a quiz app, or might be like a cart app, or a financial application app. So you can, by merging the features, you can present it to others. So basically, inverting the logic. So instead of having a layer and the features inside the layers, we have the features, and inside the features, we have the layers. So something like that. But if you see that, maybe that reminds you of something. So wait a minute and just try to think about something we said before. You remember we talked about bounded context and how the big ball of mud can emerge with bounded context to present the right features. And this is exactly what inspired this inversion of the structure. But okay, so now we know how to have features. We just have a package in our source or in our root directory that has the name of the feature, and that would be it. But they're not really isolated. And let's see what isolation means and how we can get there. So we structure the feature, and we have those 4 features. I'm sorry, and but we are not preventing the features of doing this, which means that feature 1 wants something that feature 2 has. So feature 1 has a dependency in feature 2, and feature 2 has a dependency in feature 4, and feature 4 has a dependency in feature 1. So basically, by doing like a feature approach in the structuring, it's not enough, because we are not isolating the features, and we can also end up in a big ball of mud where feature 1 actually uses some components on feature 2, and so then you cannot really have a good maintainability out of that. So we need to isolate the features. We cannot prevent it just by folder structure. And so let's see how you can isolate features. First of all, we have, as in every software development, we need to have a dry approach, which is like don't repeat yourself. So what this means is that we need to extract some common functionality and put it somewhere so everybody can use the same and have only one point where you can maintain. This can be done by exposing a shared code. All features should control which components to export through a shared interface. So we are isolating the feature, but we have to expose some bits to the outward, because we want to compose an application out of that feature. We don't want just one feature and have an app with one feature. We want to have an app with multiple features, so we need a way to compose it. And we should have a structured way of exposing the common things that the application needs. Let's say you need a menu items for constructing a menu, or the routes for routing within the application, and all that. So we need to expose those things through a shared interface. So, and a feature should not communicate directly with another feature. This is exactly what we talked about in the previous slides, that we shouldn't have dependencies between the features, but whatever the feature wants gets it from inside its own feature. And of course, we have to have a root context which should be aware for everything in order to compose the application. Otherwise, we cannot compose the application. So basically, what this can be translated into a graphical a picture is something like that. So you have your shared components or your shared code in a shared package or in a shared folder that we can create package out of that. And you can have like all the features depend on that shared, because the feature might want to have a common way of reaching out to the network, or we have a common way of dealing with notifications or whatever. This code can go to shared, and all the features then can use the same code. And we have the features that only depends on the shared and nothing else. So the dependencies here are non-existent. And we have the root. So this is like the root scope of the app, where the root needs to know about everything, about shared, about features, about everything, because the root needs to compose the application in order to have an application. So basically, the shared package, let's address that one by one. How can we have a shared package? You just create a shared folder, and you have a shared a way of having a shared code. And let's go to the second point, which is all features to control which components to expose to a shared interface. So what I'm telling here, let's say that you have a feature, and if this feature needs to be accessed by some route or some menu item. So what you can do is you can have like a feature context interface that has like a get routes that will return the routes of the feature, and will also return some menu items if we want some menu items. And this is of course indicative. It's demo code. I'm sorry. A feature should not communicate directly with another feature. This is tricky, because a feature to not communicate with another feature, it's not possible if you have them in a folder level. But we can have it in package level. So basically, right along the lib folder of our structure, we have a packages folder. Inside the packages folder, we can have multiple, all the features there as a separate library. So instead of having them as folders inside our app, we can have them as libraries inside a packages folder, and with their own path spec and all that. So there in the packages, and we have like a path spec for shared and a path spec for every feature, which has like a library. So there we can control what this feature is dependent on. So the root package spec, we have access to all of them, as we said before, because it needs to compose the application, and you can actually leverage the path option of the dependencies packages to have a direct dependency inside your own repository. So the root PubSpec has access to all the features. And this is feature 4. Let's say, for instance, all of them should have basically the same dependencies. And feature 4 only depends on shared, as we said before. And basically, with this, we can achieve this part of the isolation, which means that a feature cannot have direct dependency to other features, but only to the shared library. And we can enforce that by making them libraries inside packages. Of course, if you have a very small project, this might not seem like a good idea and a big overhead. But if you have like a big project with many people working on it, this will make more sense, because you can isolate the changes, and you can actually be sure that if you change something in feature A, it will not affect something in feature, let's say, B, because they are completely isolated. The only regression point is the shared library. And the root context must be aware of all exported components. That's the other point we had. And yeah, I just saw that in the previous slide. We can have the dependencies with a path, and we can have like our root app having access to all the features and then composing them. And you can have the app having like a root context, much like the features have a feature context, and this context can register. In this context, you can register all of your features, because you have access to all of your features. And you can register all the feature context here. So you have your features, and with the features, if we want, let's say, to build our routes, we can do so because we have access to all the feature routes because they have exposed the routes through this interface. So we can build the routes and we can build the menu items in the root level, and we can compose that and have it in the application. So this is actually this part of the diagram, which the root has access to all the features and the server. But what about state? And that's a big question, and that's a very good question because we have different state libraries. So it depends. If you have like a global scope, a global state, then this global state should be in the served library. But you have to think hard if you really want a global state, because a global state may be useful for a couple of things, but not for all of things. So maybe a feature should keep its own state. If that's the case, then you have to wire the state inside the feature and isolate it by, let's say you have a provider, you just provide in this part of the widget tree, which is the feature, and you provide whatever this feature needs. And just an example. So state, it could be like a talk of its own. So I will leave it with that. Another problem that you may face is that, okay, that you may have a dependency to, let's say, provider, which is a fairly popular package. And you have a feature A using provider and feature B using provider. If you go and have in their separate pub specs provider, then you have to maintain and you have to keep in sync the versions of those providers. Because there might be a situation where feature A and feature B might use different versions of provider. That might cause problems down the line. But if you go to the Dart website, the solution is right in front of our eyes, because in the dependency mechanism in Dart, what it says is that all transitive dependencies are actually immediate dependencies. So if you have like a package A that depends on package B, and package B depends on package C, then A, which brings package B, actually brings package C as an immediate dependency. So this means that you can put all of your libraries in the shared library. And because all the features depend on the shared library, they automatically depend on all of your third-party dependencies. And you can have all of your dependencies in one place, and you can keep track of them, and you can update one and see what breaks, and you can fix things. But basically, you will not have discrepancies between versions of the same library within your app if you leave it in the shared library, and all features depend on shared library, which actually have an immediate dependency to the third-party libraries. So basically, something like that. You keep all of your third-party dependencies in the shared library, and because feature, let's say 3, depends on shared, also depends on also brings the dependencies of all the other libraries. And so if feature 1 and feature 3 depend on provider, they only have to depend on shared, and shared needs to depend on provider, and then they can have this transitive dependency immediate in feature A and feature 3. And so how can I synchronize dependency updates? I think that by now the tool actually does it by its own. So if you do it in the root level, it will actually go in and try to see if we have prospects inside your folder tree, and will fetch everything else. But I think that's the case now. But even if it's not the case, or you don't use this version of the code of Dart, you can just create a simple script to do that, and that's that. There's not a lot of maintenance needed in the script. You just have to do it once, and then you run the script, and you get all the dependencies. So, what are the benefits of doing something like that? And so, it might seem that it is a huge overhead to try, have every single feature in its own library inside the packets folder and try to maintain that. And that might be the situation if you have something like a side project app that you have, and it's only you that you are working on it. It's fine. You can have it inside your source packets, because then you are the only one that needs to take care of the dependencies, and you can force yourself to do that. But if you have multiple people working on that, and you really need to enforce certain things, then it makes sense, because as I said before, someone working on feature 1 will not have an impact on feature thing in 3, and you will see that, and you will know that. So it has a low learning curve, because it just makes sense for me actually to have everything inside a feature. So as long as you keep using the graph that I showed, and that's your main guideline. So if something is not like the graph, then you have to change it. It's recognizable. So what this means is that if you take a look at the code, you immediately understand what this code is doing. So what this app is about. So if you open up an app and you see like presentation, services, models, and all that, and you open up like 3 of them, for all you care, all 3 apps are identical. They're doing the same thing, because you cannot understand just by looking at the file structure what this is doing. But if you have feature isolation, you have like 3 apps, you can immediately understand what's the difference between the apps and what each app is doing, like providing I don't know, maybe it's a recipe app, or maybe it's some other sort of financial app. You can actually understand what this app is doing. And this helps newcomers to the code, because because the code is more understandable, and they can actually know your business pretty quickly, because they are used to have this kind of structure. They see those keywords, they see the features all around. So if someone from business talks to them and say, okay, I need something about, let's say, a recipe, you immediately know where to look. You go to the feature, to recipe feature, and check there to see, if what you are discussing is there or not. So it's maintainable because of that. It's recognizable because of it. You can immediately understand what's going on, and have a low learning curve because you can immediately understand what's going on. And of course, it can scale. So imagine that you have like an app that 2 or 3 people are working on, and you have it like the structure that I showed, that you have all your features in the as libraries inside your packages. And let's say that you get a big fund, you have like now tens of people working on that. Maybe this will not work, although the tendency is to go to monorepos. But maybe that will not work. So maybe you want to, let's say, extract common things into their own repositories. It's fairly easy to do. You just take the library, put it in its own repository, and change the dependencies in your pubspec from path to the actual URL, and you're set. There's nothing more you can do. And then this can take the life of its own. So basically, that's what I had to say. I also have a quick demo. I think I have some time. Yeah, I do have some time. So let's try to apply what I told you into an example app. So what I have here is the provider shopper. Provider shopper is from the sample apps of Flutter, and basically, no. Anyways, if you go to the GitHub Flutter/samples, you can find this code. So what you see here, you open up the library, and again, you have common model screens. You don't really know what this app is doing at all by looking at that. If you open up screen, then you can start to understand that this is like a cart app, like a shopping cart app, and say, okay, now I understand. But let's try
Can you zoom in the code, please?
Sorry?
Can you zoom in on the code, please?
Oh, yeah. Oh, yes, definitely. Let me see.
Thank you.
Let me see. I can do that. I can view. Okay. All right. So can you see now? But it's presentation mode, and I will want presentation mode. I'm sorry about that, guys. Because I need to see the structure. And let me see how I can do that. Maybe full screen can be better. Can you see?
It's not increasing, but perhaps you can try to press Command and zoom in, like on the.
Yeah, it doesn't work. Yeah, I'm sorry about that. I should have been more prepared about in that. Maybe this can do the trick. Nope. Okay, what I'm gonna do is I'm gonna read out what I'm doing, and maybe you can. Maybe this could work. So what I'm seeing here in the library folder is a library called Commons, a library called Models, and a library called Screens. And if I open up Screens, I see a file called Card, a file called Catalog, and a file called Login. So immediately I could say that these three things are my features. Okay, so let's try to get them to their own features. First of all, we have this common, and I guess this we can just rename to be our shared. So this is our shared. And of course, we messed a bit, the things a bit up. Although, what I'm seeing is that this theme is only called in main. So actually, we can not even get it to shared. We can have it to a library just beneath like main. So by doing that, theme and main are in the root context because no one else is using theme. If someone else was using theme, then we could put it in the shared library. We have the login screen, so let's make a feature of that. And a feature could be what I usually call it is access. So it's like an access bounded context. So I have created a folder called access here. And I will just put the login screen to the access feature folder. And that's okay. And I see a screen called catalog and also a model called catalog. So let's create a feature called catalog. So I am creating a folder called catalog. And I am taking the screen and I'm putting in the catalog feature folder. And I have a model called catalog. And it's also called, the file is also called catalog. So I cannot just drag it there, but I can actually, inside my feature, create a model folder and get my catalog model and put it there. So this kind of makes sense. We have our catalog and we have our screen. We can also create a folder called screen, but we only have one, so I just leave it there. And what's left is the card. So let's create a directory called the card. And let's take the screen and drag it to the card feature folder. And we have it there. And we also have a model called card. So again, let's create a model inside the card feature folder. And inside there, we can drag our card model. Okay, so now models and screens are empty. We can just delete them. And now what we can see is, so if I open up the folder, now I can see that, oh, I see I have an access folder, a cart, and a catalog. Immediately I understand that this is a shopping cart application, probably. But is that enough? No. Let's see if those are isolated. Let's see if we have an interdependencies between those features. And actually, if I go to the catalog, I see in the imports, I see the cart model. So let me go to presentational mode. I see this. So I see that my catalog is actually using the cart model, and it's using it in order to store the selected models. So let's see if we can get away with removing this dependency. Of course, we have some broken things here, but what we can do is, instead of getting the cart model, which is a component specifically for cards, we can actually extract what we want. So what we want here is something that has a method contains and something that has a method add. So basically, we need a product keeper. We need some component that you can add some bunch of products and you can see if a product is contained. So let's try to do something like that. How we can do something like that? We go to the share folder and we create this interface, which is let's say a product keeper. And this is maybe I can switch now to, yeah, sorry about this. Let's create an abstract class. No, abstract class called product keeper, and it will get like something. We'll just keep a list of something. So what we need a method that checks if this product keeper actually keeps a product. And also, we need a method to add products. And for reasons you will see later, we can have that extend into notifier. So with this interface, now we can actually isolate the feature. And let's see how we can do that. Because now I can go to the catalog and I can say, hey, I don't need a cart model. I just need a product keeper of items. So please provide me with that, and I will check if it contains this item. There's one fixed. Second one, again, product keeper from the provider. All right, so now we have fixed catalog, but probably we have broken the app because it doesn't know how to provide that. So if we want to do something like that, we can go to the main and can go where the providers live, and we can actually have a change and notifier provider, and have a change notifier provider, proxy provider actually, and we need to get as a dependency the cart model and return a product keeper of item. Okay, so how we can do that? We have to have cart model extend or implement their product keeper. So if I go to the cart model here, maybe I can switch to presentation mode now.
I think you can just press Command and try to zoom in with 2 fingers on the code when it's in ordinary mode. That would.
Oh, okay. Okay.
Let's try to do that.
Yeah, let's do that. I'm sorry, guys, about that. Should have been more prepared.
No problem at all.
Yeah. Perfect. Thank you, whoever helped
Great.
out with this one. Thank you very much. So I don't know if I can do that here as well. No, but at least we have the code here. So card model will not have a card model extend change notifier. We will have it extend our product keeper with item. And of course, we have to implement one override that we don't have, which is contains. And what we can do is we can actually recreate the logic that was in catalog, which was that you get the items and you call contains on the items. So now, and this one, we are overriding that. So no complaints, nothing, everything is good. Let's go over here now and let me zoom again. And now what we have to make this work. So in order to make this work, we have to have, we have to have this, we are getting a card model and we are having a provider. We will not create anything, and this is not a provider talk, so I will not get into much details about why we are doing certain things here. And I think I messed up something. Yep, I need another parenthesis here, I guess. I'm not. All right, let's take it back and fix that. We have the change notifier provider, getting card model, an item. Yeah, of course, this is what I was missing. And now we have an error here because we need to have that, but we actually don't because we are getting it from the proxy provider just up from that. And we need to have an update, and of course this needs to have an argument. And we don't care about the context, we only care about the card model. And we don't care about what we have created. And we are basically going to say, all right, if someone asks for a product keeper, just get the old card model back. And why we're doing that? Because we need to keep the card model and the catalog connected. So we're doing that, and everything seems to be fine. So let's try to run the app and see if we have broken it. And I'm gonna both reload. All right, everything is here. Let's see, I enter. And I have a small error here that goes away. This is a bug that, I don't have the time to fix it probably, but we have everything here. If I add it to the card, I get the check mark, which means that they get connected. If I go to the card, I see the control flow here. So basically, we have managed to get the app from a folder structure that didn't give you a clue of what was going on to a folder structure that you can actually understand what's going on. And we have isolated it. I don't have the time to get everything in the packages folder and make them proper isolate, but I think that's enough for a demonstration. And I don't know if I have more time, but that's about it. I can get questions now.
Okay, thank you. Actually, I saw that architecture in Dart SDK repository, and it didn't make much sense to me when I first saw it, but after your presentation, it all makes way more sense and looks more reasonable.
I'm happy to hear that.
Okay, now to the questions. The first question is, have you tried to create private pub server in order to share shared libraries?
No, I haven't tried doing that. But what you can do is you can actually have your repositories connected. So instead of having something to in order to have a dependency into something that's already built, you can have a dependency directly to your repository code. So if you want to split it up to different repository in your URL, in the dependency in the pub spec, you can have, instead of path, you can have URL, and you can give the Git URL. You can also give like certain branches or certain, it is a very fine grain how you can have a dependency. But I haven't tried private pub spec. I have tried the Git repository connection.
Okay, thank you. Another question is, how would you use CI with shared libraries to be sure all dependent projects are tested with latest versions of shared libraries?
Okay, so as I said, if you change something in shared libraries, all of the features are going to get the same thing. Mm-hmm. So what you have to do is change the library, run your tests. If nothing breaks and you have enough tests, then you have like a high assurance that you didn't break anything. If you have manual tests, you can also do that and send it to your internal testers or whatever team you have to check it out. But basically, because you have all your third-party dependencies into a single point, which is the shared library, if you change something there, every package is going to take it. If the package has only one dependency, which is the shared library.
Okay. And how would you handle the global information like user connection state? For example, in cart, user wants to pay but is not connected. How would you manage that?
So this is something that, so authorization is something that all of the packets need, all of the features need in order to be there. So basically what you want to do is you have to have, your feature needs to have certain permissions. And you can enumerate those permissions in certain roles. And what each feature wants in order to present something or not, or allow an action or not, is to see if the user is not the user itself, but the permission of the user. There might be a situation that you might want the user itself, but we are getting very deep into domain-driven design with this, because a user in a certain context, so in an access context, you may have like a user. But let's say in a catalog context, you have a customer, which may be the same. They may share some common information. So basically, you can have a user in your access model, and you can have a customer in your catalog model. And if you want to see if this customer is logged in or whatever, you access this customer. And so how can you get it? You can go to your global store, which is abstracted. So you can use like an adapter for that. We're way deep into that this bit, but maybe it will make sense and will answer the question. So you have an adapter that will get you certain permissions, or you get you some other things. Probably much like what I did with the product keeper. So a product keeper was an abstraction. It was implemented by another feature, but the other feature had it without knowing about it. So basically, you can do something like that.
Okay, great. And another question is, what problem would we run into if we didn't isolate features?
Yeah, so all problems are fixable, okay? And all architectures can work. I'm not like heavily advocating on that. But what I'm saying is that if you isolate your features, you can prevent interdependencies between your features. So you can prevent a certain, let's say, junior developer or a developer, despite his or her level of seniority. It will prevent him or her to get a component from another feature. So most of the times what we see is that, okay, I have a feature, I need this one. Oh, this certain thing is implemented in this other feature. So I can just grab it from the other feature. So if you do something like that and you create an interdependency, you can change this feature in the other, let's say, component in the other feature, not knowing that the other feature has a dependency on that, and you can break the other feature. Fixing your feature, but breaking the other feature. But if you eliminate all the interdependencies, then there is no way you can break other features by changing something in one.
Okay.
I don't know if I answered it.
Yeah, thank you. And do you think if there are any disadvantages of this architecture?
Okay, so the only disadvantage I would see is the overhead, because it's a different thing to have, everything in one thing, one directory, and maybe structure it the way you want it, and another way to have it in inside the packages folder, which is all library and all that. And as I mentioned in my talk, probably this package, so the isolation part, not the feature packaging of the part, but the feature isolation part, might not be eligible for, let's say, a team of 1 or 2 people that they can communicate and say, okay, you have to change it, we don't do something like that. They can follow guidelines. But you have a big team, this makes a lot of sense, because you can actually prevent yourself from present your team from shooting itself in the foot by a feature dependency and all that. So the drawback would say that there is some overhead, but other than that, I don't see any other major drawback.
Okay, thank you. And I guess you can say that those principles are inspired by web development and Angular. And do you think that Flutter tends to be more like a web application or a mobile application?
Yeah, so I really like the way that they were using modules in Angular, because they can enforce the things that I had just presented. You can enforce them by using modules, and you can, because the module can actually have imports and exports, and you can control what's going on inside the module, which should be a feature. But in Flutter, we don't have that. And I was trying to figure out ways how can I enforce that. And this is what I came up with.
Okay. Well, thank you very much for your presentation and for everything you do for the community. Thank you very much. We were really glad to have you here. And we hope that you'll be able to join our listeners at Spatial Chat and talk to them.
Sure. I will be there for a few minutes after the talk.
Okay, great. Just in case you forget
Thank
the
you very
link.
much.
Okay, bye.